Halohydrin Formation of an Alkene. This is alluded to in the epoxide formation one. The overall reaction, we'll use Cl2 this time, and water will take you to a chlorine on one and a hydroxide on the other. When you have a alcohol and a halogen side by side, 1-2 positions, that is called a halohydrin. And this is cool because once you take away this proton here, the oxygen could come in, knock off the chlorine, and give you an epoxide, which is super helpful in synthesis. Full stop. The reaction is thus. There we go. The pi electrons in this alkene here are going to be your nucleophile. This is your dichloro molecule. They have the same electronegativity, so you would think that both are neutral, but according to dispersion forces, there is sometimes more negative on one side, more positive on one side. So at any time, you could just say that's a delta minus. You could say that's a delta plus. Those look like 2's, but that'll have to do. Start your arrow from your nucleophile. Damn it. Start your arrow from your nucleophile, land on your electrophile, take out your leaving group, just like any other reaction you've done ever. Draw your intermediate. We'll put the chlorine on this one this time. These two electrons grabbed the chlorine, so that made a C-Cl bond, but you also took electrons away from the other thing, so that gives you a positive charge. But Riley, if there's a positive charge, where's the negative? She's right there. It's okay. Don't worry about it. Now, if you just used Cl2, this could come back in and make the dichloro molecule. But if you have water in higher concentrations, it will be the favorable nucleophile. So let's draw a little water guy here. Got some lone pairs on her. From your nucleophile, I did it again! From your nucleophile to your electrophile. There's no arrow out because you're putting it into an empty orbital. You don't have to break a bond. No. How do I can I do this? There you go. Where am I? You added a water here. I'm going to call it OH2 with a positive charge. Cl there. There's a positive charge. Where's the negative? It's still there. It's okay. Don't worry about it. Now, what I did here was poorly draw this OH2 plus, because now I can't finish the rest of the mechanism. So, I'm going to draw an O there, H like that, and H like that, a positive charge there. That's how you should really do it, because now your Cl is going to grab the hydrogen. These two electrons in this bond are going to plop onto there. Okay, let's not try scrolling down again, because that was a fail. We'll just go to the left. You now have a halohydrin. What was this titled? Halohydrin Formation of an Alkene.